My name is Paul Ruth. I'm from UNC Chapel Hill. I work at a research institute called RENCI that has been mentioned quite a few times today. And I'm here today to talk about our new programmable core network testbed that will span the nation coming soon. NSF just gave us $20 million to build this last October. So what I'm talking about today is not yet built, but it hopefully will be soon. And we're looking to get feedback from everyone about how to build it and what you want to see in it. So for starters, this is the team that we're working with. So Ilya Baldin at RENCI is our fearless leader and the PI of the project. Anita Nikolic is second in charge. I'm going to skip several things in this talk in order to go a little bit faster so I can get through most of the things I want to talk about. But there's a bunch of other people on the project. These are just the leadership team. There's even many, many, many more groups that are involved. So the motivation behind this, keep in mind this is a programmable core networking testbed that's going to span the country and connect all your clouds and all your facilities. And the motivation behind this is that the internet has existed for a while. It was designed decades ago. There was certain things, certain limitations that they had, constraints they had when they were designing it, and it's showing its age a little bit. If we had some of the devices and capabilities that we had today, maybe we would have made slightly different choices back then. But since we have TCP/IP and we have routers and we have the systems set up the way they are, we pretty much have no choice. There's the narrow waist of the stack, and we have for years been designing all of our software around this. But this testbed will allow us to do some experiments to see if there are other possibilities out there and let people be a little bit more creative. So what's changed? Well, compute and storage is a lot cheaper than it used to be. We can think about putting it everywhere in the network, for example, and it's not really going to cost that much compared to everything else. We have all these really cool network programmability tools like OpenFlow and P4 and DPDK and all of these other things, and probably more will come along the way. These didn't exist back then. Now that we have these software-defined networking capabilities, put them in the core of the network, let experimenters use them, see what they can come up with. Machine learning and AI, which is just changing everything in all different ways. And really our applications are very different. So everyone has a phone in their pocket that'll soon be 5G. There's IoT devices everywhere. No application is a standalone application anymore. There's always some sort of cloud piece. So the networks are really just part of the applications these days. They're not these end-to-end things that we used to think about it. So we have opportunities to change some things. This is just a test bed that will allow people to experiment with it. We have no horse in the race to see what technologies win. This is just a test bed to let people try to do things that they can't do with the internet as it exists today. So what are we actually going to build? Well, there's two pieces to this. There's the core of the network, which is in this map here, and there's going to be the edge of our network, which I'll show in a little bit. In this picture, there's 9 sites around the country that we're going to actually get hardware and put it in there. The core of this network is going to sit on top of ESNet 6 footprint, which is ESNet 6 is currently being built right now, so we're sort of dependent on their rollout before we can roll out. And at each of these sites, we're going to have, you can think of it as like a rack of networking gear, like P4 switches and programmable things and storage and compute and connections. Between them, we're going to ride on top of ESNet 6 again, and we're going to have dedicated optical links where we own the lambdas on the optical links. The blue links up there will be 100 gigabit connections that we own the whole 100 gigabit. The yellow supercore is going to be a terabit link, which we own the whole terabit. Now, of course, probably right away, no one's going to use the whole terabit. But since we have a terabit, that means I can give you 100 gigabit and you 100 gigabit and you 100 gigabit, and you won't get in each other's way, right? So that's the idea behind that. Also interesting in this picture is we don't really have any edge compute in our system, and that's by design. So instead of us providing the edge for you, we're just going to connect to all the real things. So for example, we're going to have another site in the MGHPCC. We'll have it in all of these different NSF cloud sites and high-performance computing centers and various regional networks and all of this all around. And you will be able to then connect your real facilities into this network and design topologies that go across it, and possibly even connect it into the public clouds via internet too. So this is the core of our network. There's actually 4 more core sites that we haven't decided where we're going to put them, so they're not on the map yet. 13 of them total. There will be 16 more sites that will look just like this, except they'll be in different regionals. Like, for example, the one that's in MGHPCC, or will be in MGHPCC, will be one of the 16. We're going to do our best to connect all of the other 16 sites with dedicated optical layer 1 connections at 100 gig if possible. We do realize that not all 16 of those will be amenable to that, so we're going to do whatever we can to get the best connections we can. The 16 sites, these are our other partners that are on this project. There's lots of them. UMass Amherst is the group that signed the letter for us, so that's why their logo's there, not MGHPCC. All of these places will have some affiliation with us for some connectivity or some sites, or maybe they have applications. They're all getting paid money out of this somehow, so that's what these are. And these would be the edge of our network. So people that have maybe seen this presentation before probably haven't seen this slide. We're actually making progress towards designing things now. So this is where the concept behind the fabric core will look like. So in this picture, there's sort of 2 main colors. The gray color is the things that we will run, the administrators will run this. The yellow, tan colored ones are the ones that the users will be allocated. The users can create these resources. So if you see here, we got this switch down here, the data plane switch at the bottom. It's got, in this picture, there's 4 links that go outside. You can kind of imagine those as being 100 gig links going in some degree to other fabric nodes. We have maybe a P4 switch or maybe several P4 switches. P4 switches can only be controlled by one group, so that if we have a P4 switch and we allocate it to you, you will get full control over that. Over here we have nodes that are just regular compute nodes, and in those nodes they'll have all sorts of programmable things, all the things you want, all the things we've talked about. I won't go into it so we can save some time. And we will use this data plane switch here as basically a patch panel to take ports on all these different pieces and plug them into ports on all the different pieces. So you can get a P4 switch connected to your FPGA as a bump in the wire, connected to a circuit that goes at 100 gig across the country to some other node that looks basically the same, right? That's kind of what we're doing. Or you can have it go out our data plane switch and connect to some big facility inside, for example, the MGHPCC. And that's kind of what we're going for here. So an example might be like this. So we have something you might deploy would have a bunch of sites, maybe a P4 switch in Texas and some set of smart NICs in the middle of the country, come to the West Coast through a bump in the wire site that connects to some external resource in California. And you can design this. These are all dedicated to you. You get bare metal access to all of it, connect it up to your real things, run your experiment. That's the idea. We get this. We have to make sure we talk about this. So there's a lot of stuff going on here. The real takeaway here is this is a programmable core network. What we want you to do with this is to do things you can't do with the internet. So we want you to program the core, put state in the core, things like that. What we don't want you to do is say, I got a bunch of genomics data on the West Coast and I'd like to get it to the East Coast. That's for someone else to do, Internet 2 or something like that. We can work with you to make that happen, but that's not what we're here for. We're also not for production traffic. We're more for experiments. But we do want to serve as an incubator to take your experiment to like a semi-production state so that you can then like test it out with real traffic, and then we can go to Internet 2 or someone like that and get you a real place to deploy it. So we want to incubate you. The timeline, so we're still in year 1. We got funded in October. We're still planning. Starting in year 2, we're going to be deploying the real devices, a small subset. And then years 3 and 4, we're going to deploy the rest of it. Probably by next summer, somewhere near the middle of year 2, we'll want to get real users on it for a small pared down version of the topology. But it'll exist, so we invite you to come try to use it. If you want to get involved, we have a website. You can go here, whatisfabric.net, click on the Get Involved button, and there's a little form you can fill out. You just be on our mailing list. We'll tell you about workshops that we'll invite you to and things like that. And, whoops, go to the next slide. It doesn't want to. There it is, okay. And NSF paid for this, so thank them too.